All right, welcome back, everyone, for another deep dive. Today, we're going to be talking about something pretty mind-boggling. Can life exist around white dwarf stars? You know, those stellar embers that are left behind when stars like our sun kind of, well, burn out.
Yeah, it's such a cool idea. I mean, we often picture life flourishing around, these vibrant, active stars like our sun, but white dwarfs, even though they seem quiet, might actually be a really long-lasting place for life.
So we're not talking about like our typical stars here. These are the remnants. What makes them so interesting for life then?
Well, the key is how they cool down. As white dwarfs lose energy, the habitable zone, that sweet spot where liquid water can hang out, it actually shrinks inward.
Wait, the habitable zone shrinks, so a planet that's like too cold at first could warm up as the star gets older and that habitable zone moves in.
Exactly. It's like a cosmic dance. Think of a planet, it starts out covered in ice and then it slowly thaws as the habitable zone kind of like engulfs it. And the paper we're looking at today, it actually suggests that a planet could stay livable for a crazy long time under these conditions.
So longer than a planet like Earth around a star like our sun. That's a pretty big claim.
It is, and the paper puts some numbers to it too. They think that an Earth-like planet orbiting at just the right distance could stay habitable for almost 7 billion years. That's even longer than we think Earth will be habitable.
7 billion years. Whoa, that's a long time for life to, get going and evolve. Okay, but hold on. We've got this shrinking habitable zone, but would a planet like that even get enough light to, I don't know, support life? White dwarfs are pretty faint, right?
You're right, and the researchers actually looked into that, specifically whether there would be enough light for photosynthesis.
Ah, so could plants even survive in that kind of light? Would they need to be, like, super efficient at capturing energy?
Well, here's the really cool part. Their findings show that the entire habitable zone for these planets gets enough light for photosynthesis, just like we see on Earth.
No way. Seriously.
Yeah.
But wouldn't the light from a white dwarf be different? I mean, wouldn't that affect the plants?
It is different in terms of like the total amount of energy, but get this. The peak wavelength of light from a white dwarf during this habitable period is almost exactly the same as our sun's. So plants on a white dwarf planet might not look all that different from Earth plants.
Wow, now that's fascinating. We're talking about a completely different kind of star. But life could still use the same way to get energy as it does here. That's pretty mind-blowing.
It really shows you how, I don't know, universal some of life's processes might be. And it makes you think, what about how life starts around white dwarfs in the first place? Could the right conditions even exist?
Yeah, right. We've got this habitable zone, enough light for plants, but how about those very first steps towards life? What did the paper say about that?
Well, they looked at the role of ultraviolet radiation, specifically a type called UVC, which we think is important for those early chemical reactions that might have led to life. And they found that across that whole habitable zone around a white dwarf, the UVC levels would be enough to maybe, kickstart those early stages.
Okay, so these white dwarf systems could be surprisingly good for life starting up,
Mm.
not just for keeping it going once it's there. But here's the thing. Could a planet like Earth even get into that habitable zone around a white dwarf to begin with? I mean, when a star turns into a white dwarf, wouldn't its planets get totally messed up?
That is a big question, and the paper definitely acknowledges that. When a star becomes a white dwarf, its planets go through a wild ride for sure. Some might get flung out of the system completely, others might end up too close and get, like, ripped apart by gravity.
Yikes, that sounds pretty chaotic. So
Yeah.
how could a planet survive that, let alone end up in that nice habitable zone?
Well, there are a couple of ideas. One is that new planets could actually form from all the leftover stuff swirling around the white dwarf, like a second generation of planets born from the ashes.
Oh, a second chance at planet formation. That's a cool thought. Are there other ways a planet could get in that habitable zone?
Yeah. Another idea is planetary migration. Some planets get destroyed, yeah, but others might move inward without getting torn apart. It's almost like a cosmic game of musical chairs, with planets shifting around as the star changes.
So it's not just about surviving, but maybe ending up in an even better spot than they started. Wow, okay. But I gotta ask, did this paper actually find any planets in these habitable zones around white dwarfs?
Not yet, no. This research was more about the potential, like modeling and exploring possibilities, not actually observing planets. But what it does is give us a good reason to look.
So it's like, hey, this is worth checking out, like laying the groundwork for future discoveries.
Yeah, exactly. And they even looked into whether we could actually observe these planets with telescopes we have now. And guess what? It looks like observing these planets with something like the James Webb Space Telescope is totally possible.
Whoa, hold on. We could actually see planets around white dwarfs and maybe even look for signs of life.
It's definitely possible. And what's even cooler is that we wouldn't need to observe them for years and years. We might be able to look for signs of life, those chemical fingerprints in the atmosphere, in just a few hours.
Oh, this is getting me really excited. White dwarfs have gone from being these quiet, dead stars to like frontiers in the search for life. But before we get ahead of ourselves, I'm curious about those observations. What kind of signs of life would we even be looking for?
Well, this is where it gets really cool. Remember how we talked about white dwarfs being way cooler than our sun? That means those habitable zones are much closer in. And since the planets are huddled up close to their star, they're way more likely to transit, pass in front of the star from where we are.
Oh, right, yeah, and that's perfect for studying atmospheres because the planet's air is like filtering the starlight, so we can analyze what's in it. So these planets around white dwarfs, they'll be great targets for finding signs of life.
Absolutely. And there's another bonus here. Because white dwarfs are so small, the signal from a planet passing in front is way stronger compared to the star's light. So it's easier to see those little changes in the starlight that the planet's atmosphere makes.
So it's like we get a clearer view of the planet's atmosphere because there's less, I don't know, background noise from the star.
Exactly. It's a huge advantage for this kind of research. Now, as for what signs of life we'd look for, some of the usual suspects are still good, like oxygen, ozone, methane.
Those are like the classic ones, the ones we think of for life on Earth.
Hmm?
But wouldn't the conditions around white dwarfs maybe lead to different signs of life? Things we haven't even thought of because, well, we only know about life on Earth.
That's a great point. The light from a white dwarf is different, so we might see biosignatures that wouldn't be as obvious around stars like our sun. The paper even suggests that the specific mix of gases in a planet's atmosphere could tell us what kind of photosynthesis is happening.
Hold up, different kinds of photosynthesis. I thought it was just plants using sunlight, water, and carbon dioxide to make food.
That's the one we know best, yeah. But on a planet with that unique white dwarf light, plants might have figured out totally different ways to use that energy. They even say some planets might look reddish because of the kind of photosynthesis going on.
Red plant life, but not because of iron oxide like Mars. That's wild. Okay, so let's say we found a planet around a white dwarf. It's transiting, and we point the James Webb telescope at it. What are we actually looking for in the data to say, yep, there's life there?
It comes down to finding specific patterns in the light that passes through the planet's atmosphere. Remember how different molecules absorb light at different wavelengths? That creates a unique fingerprint for each one. So if we see dips in the starlight at the wavelengths where, say, oxygen or methane absorb light, that's a strong hint those molecules are there.
So we're like cosmic detectives,
Yes,
using light to find clues. But we got to be careful, right? Couldn't those gases be made without life?
You're absolutely right. We have to watch out for false positives. That's why finding a few different biosignatures together, especially ones that wouldn't normally exist together without life, would be much more convincing.
Like a combo of gases that wouldn't just hang out together naturally unless something alive was keeping them balanced.
Exactly. And that's where the next step comes in. This paper was about the theory, but now we need to put it to the test. Look at real white dwarf systems and see what we find.
It's like we've got this treasure map, and now the real adventure starts. But I gotta wonder, with all the challenges we've talked about, could life around white dwarfs be more than just, microbes or simple plants? Could there be enough time for intelligent life to evolve?
Now that's thinking big, and you're not the only one wondering about that. Some scientists think that if life did start up on a planet or in a white dwarf, it might have billions of years to evolve, maybe even longer than life on Earth.
So we could be talking about advanced civilizations, maybe ones with tech way beyond ours.
It's a pretty exciting possibility, and if that's true, we might be able to detect not just biosignatures, but technosignatures too, signs of tech made by intelligent beings.
Whoa, now we're getting into sci-fi territory. What kind of technosignatures would we even look for around a white dwarf? Like massive space stations, beams of light shooting across the galaxy.
Those are possibilities, but there could be subtler signs too. For example, if they were using the white dwarf's energy in a big way, we might be able to spot some weird energy emissions or patterns in the star's light that don't make sense naturally.
So it's not just about finding radio signals or giant structures, but being open to, like more subtle clues.
Exactly. We have to think outside the box and consider all the ways a really advanced civilization could leave its mark on a star system like that.
Okay, so we've got these potential techno-signatures, but how would we actually search for them? Would we use the same telescopes and stuff as we do for biosignatures?
A lot of the same tools work, but there are special ways to search for technosignatures too. For instance, we can look for very specific kinds of radio signals that nature probably wouldn't make.
Like signals that are obviously artificial, like a beacon shouting, "Hey, we're here!"
Yeah, exactly. Or we could even look for signs of pollution in a planet's atmosphere, just like we can detect pollutants in Earth's air.
Wait, so we could see alien smog from light years away?
It might sound wild, but it's the same idea as studying our own planet's atmosphere. Of course, this is really hard stuff. We're talking about faint signals against, like, a whole universe of noise.
Like finding a needle in a haystack, but on a cosmic scale.
It really is. But the potential payoff is so huge, it's totally worth it. If we found evidence of a super advanced civilization around a white dwarf, it would change how we see our place in the universe completely.
Yeah, it'd be huge, proving we're not alone, and that life can not only survive, but thrive in places we thought were impossible. But let's bring it back down to Earth for a sec. We know our sun will become a white dwarf eventually. What's that going to mean for our solar system?
That's a great question. As our sun ages, it'll become a red giant first, swallowing up Mercury and Venus, and maybe even scorching Earth.
That was pretty rough for the inner planets.
Mm.
But what about the ones further out? Could they actually benefit from the habitable zone changing?
That's the really interesting part. When the sun shrinks down into a white dwarf, its habitable zone will move outward and might actually include Jupiter and Saturn. Now, those gas giants wouldn't become habitable themselves, but their moons might.
Whoa, are you saying moons like Europa or Enceladus, the ones that might already have oceans under the ice, could actually have oceans on their surface billions of years from now?
It's a pretty crazy possibility. Imagine those icy moons turning into ocean worlds, maybe even with continents and islands.
A second chance for life in our solar system, but on a whole new stage. That's an incredible thought. But wouldn't life on those moons have to deal with some, I don't know, unique challenges, even if they had a habitable surface?
For sure. Their gravity is much lower than Earth's, so holding onto an atmosphere could be tough. And the light from a white dwarf, even though it's enough for photosynthesis, is still much dimmer than sunlight, so that would affect what kind of life could live there.
So we're talking about a totally different set of rules for evolution, which could lead to life that's completely alien to us.
It really shows how adaptable life is. It might find ways to thrive in environments we can't even imagine.
This deep dive has been a whirlwind of information and, honestly, some wild speculation. Life, technosignatures, the future of our own solar system, all because of these fascinating white dwarfs. But before we get too lost in dreams of aliens and future oases on Jupiter's moons, let's go back to the science for a minute. What are the key takeaways from this paper that we really want our listeners to remember? What makes these white dwarf systems so interesting beyond just the wow factor?
Well, I think one of the biggest things is that white dwarfs show us a whole new way to think about habitability. We've been so focused on stars like our sun, thinking that's the only place life could be.
Yeah, it's like we've been using Earth as like the model for what a habitable planet should be. But this is saying maybe we need to think bigger.
Right. White dwarfs are telling us that habitability is way more diverse and complex than we thought. It's not just about finding an Earth-sized planet in that Goldilocks zone. It's about looking at the whole history of a star system and how that could affect life's chances.
So it's not just a snapshot, it's like a whole movie of how things change. And white dwarfs give us a unique look at that because they're like a later chapter in a star's life, right?
Exactly. By studying white dwarfs, we're kind of looking into the future of our own solar system. And what we're seeing is that even though our sun will die eventually, that doesn't mean the end for life around here.
That's kind of comforting, but also mind-blowing at the same time. Okay, but let's get practical for a sec. If we really want to find out if there's life around white dwarfs, what do we do next? What kind of research is needed?
Well, for observations, we got to keep using telescopes like the James Webb to find and study those planets around white dwarfs. The more planets we find, the better we'll understand how different these systems are and what the chances for life are.
So it's all about getting more data, like seeing what's out there and what patterns pop up.
Yeah, exactly. But it's not just about observing. We also need to keep making those theoretical models and simulations, to explore the stuff we talked about, planets forming, moving around, how those systems change over time.
So observations and modeling, working together to get the full picture.
Exactly. And of course, we need to keep pushing the limits of technology. If we want to find techno-signatures, we need even better instruments and new ways to look for them.
It's like science is this never-ending journey, always trying to learn more and understand the universe better. But I think it's safe to say this research has opened up a whole new chapter in that journey. It's changed how we think about where life could be and how we might find it.
I totally agree. White dwarfs, which we thought were like cosmic graveyards, have become these exciting new places to look for life. They make us rethink what we know, spark our imaginations, and show us how much we still have to discover out there.
Well, this has been an incredible deep dive, learning about the science and, honestly, the mind-blowing possibilities. A huge thanks to our expert for taking us through all of this. And to all of you listening, thanks for joining us on this journey of cosmic exploration.
It's been my pleasure. Keep those minds open and those telescopes pointed at the sky. Who knows what amazing things we'll find as we keep exploring this vast, mysterious universe.
Until next time, keep exploring.